So in last class, we have done how to find the rank of a matrix, Gauss order method, and then normal form of a matrix, right? And after that, we have started system of linear equation. So we do have two types of system of equation. One is non-homogeneous, other is homogeneous system of linear equation. Non-homogeneous system of linear equation is represented by Ax is equal to b when right hand side of equations is not equal to 0, then system is your non-homogeneous system, right? And if right hand side of equation is equal to 0, then system is known as homogeneous system. This is your coefficient matrix. This is known as augmented matrix, right? This is known as augmented matrix. Augmented matrix can be created just by adding one column to the coefficient matrix. This is your system of equation, and we have done how to write the coefficient matrix. So you need to write all the coefficients of x, y, z, and then this right hand side for augmented matrix. In coefficient matrix, we will write only this part. Coefficient of x, y, and z. 3 minus 2, 5, minus 2, 1, 4, 1, 4, minus 7. Right? Now in augmented matrix, this is your coefficient matrix, and we will be adding one column that includes values of right hand side values of given equation. That column would be 3, minus 2, and 1. Next, consistency of system means existence of solution. System can be consistent or inconsistent. When system has one or more solution, then system is known as consistent, otherwise inconsistent. So we'll check whether system is consistent or inconsistent. We will check that consistency using rank. If rank of coefficient matrix is not equal to rank of augmented matrix, then system has no solution and system is known as inconsistent. Consistent system, if rank of coefficient matrix is equal to rank of augmented matrix, and that is equal to number of variables, then system has unique solution. Other case, if rank of coefficient matrix is equal to rank of augmented matrix, and that is less than number of variable, then system has infinite many solution. So if system is having unique solution or infinite many solution, then system is known as consistent system. Right? Now, we do have an example. Solve the system of linear equation x plus 2y plus z is equal to 1, 3x plus 5y plus z is equal to 3, 2x plus 6y plus 7z is equal to 1. Right? Everyone, please be with your notebook and pen. Right? So now this is your given system of linear equation. So what will we do? First step, we will write augmented matrix. We will write augmented matrix. And what it would be? This is 1, 2, 1, colon 1. Then 3, 5, 1, colon 3. Then 2, 6, 7, and colon 1. Right? First step, write the augmented matrix from given system of linear equations. Right? So you have written augmented matrix. Then we need to convert this into echelon form, right? For finding the rank of coefficient matrix as well as augmented matrix, right? So we can find rank of coefficient matrix as well as rank of augmented matrix from this augmented matrix, right? So after making this augmented matrix, you need to convert it into row echelon form. For that, we will make this entry 0, as well as this entry 0, right? So you will be applying the operation R3 implies, sorry, first we will go for R2. R2 implies R2 minus 3 times of R1, right? For making this entry 0, R2 implies R2 minus 3 times of R1. And for this, R3 implies R3 minus 2 times of R1, right? Do it, hurry up. Do this calculation. Hurry up.
Ma'am, may I tell?
Yes, Shubham.
Yeah, ma'am. The second row will be 0, -1, -2.
Just wait for 1 minute. I'm writing it over here. Yes, beta. First row is 1, 2, 1, 1 as it is. Next one is 0. Yes.
-1, -2,
Minus 1, minus 2,
and then 0.
and then 0,
And then third will be 0 to 5,
0, 2, 5,
-1.
-1. Thank you, beta. Now, for row echelon form, this 0, this 0. Next target is we need to make this 0, right? So for making this 0, we will apply operation R3 implies R3 plus 2 times of R2. Is it right, beta? We need to make this entry 0, so we are applying R3 plus 2 times of R2 because it is 2 and this is 2 into -1, -2, that would become 0. Now solve it, simplify it, and then let me know. 1, 2, 1, colon 1. Now 0, -1, -2, and then 0. It would be 0, and then this 0, and then it is 1, and then last entry would be -1. Check it. Are you getting same? Yes or no?
Yes, ma'am.
Same, no?
Yes, ma'am.
Now, after this, I need what? This is row echelon form. Number of zeros are in increasing order, right? So now I need rank of coefficient matrix as well as rank of augmented matrix. Then only I can check whether the system has unique solution or infinite many solution or no solution, right? For checking consistency of given system of equation, I need rank of coefficient matrix and rank of augmented matrix. Now, you tell me what is the rank of augmented matrix? Tell me rank of augmented matrix.
Ma'am,
Yes,
3.
beta? 3. Number of
Ma'am,
non-zero
3.
rows are 3. So, rank of augmented matrix is equal to 3. Now, rank of coefficient matrix. For rank of coefficient matrix, we forgot this column. And we will concentrate only on this, right? And this is your coefficient matrix. Now you will check number of non-zero rows in coefficient matrix. Again, there are 3. So you are writing rank of coefficient matrix is equal to 3, right? So only finding the rank of augmented matrix or converting the augmented matrix into row echelon form, you can find rank of coefficient matrix as well as rank of augmented matrix. Convert it into echelon form and then count number of non-zero rows. It will give you the rank of augmented matrix. For coefficient matrix, we will forget this column, right? And this would be your coefficient matrix. So now again you can count number of non-zero rows. So that is again 3. So if rank of coefficient matrix, rank of augmented matrix, both are equal, then system is what? System is consistent or inconsistent?
Consistent.
Consistent.
Inconsistent.
Inconsistent means beta no solution. Rank of coefficient matrix is equal to rank of augmented matrix. If both are equal, then system is consistent. Consistent means system is having solution. Both are equal and that is equal to number of variables. It means system has unique solution. Right? So this system has unique solution. After checking this, you will rewrite your equation through this matrix. Now, how you will read it? This entry was, I think, 1, right? So now you need to read it out. This represent for X, this for Y, and this for Z. So how you will read it? From last row, we will be starting 0x plus 0y plus Z is equal to minus of 1. Right? And from this, minus of y minus of 2z is equal to 0. And then you will be putting your value of z in this and corresponding you will be getting y. And then x plus 2y plus z is equal to 1. Then you will be putting your z as well as y and you will get the value of x. Right? Now I'll show you complete solution. Now let us start. This is your augmented matrix. The goal is row echelon form, right? So we will be making this entry as well as this entry would be 0. So let us start. You need to make this 0 as well as this 0. So you applied the operation R2 implies R2 minus 3 times of R1 and you are doing this calculation and then matrix is this. Now you need to make this 0. So you will be applying R3 implies R3 minus 2 times of R1. Right? After getting this goal is achieved. Next is for this. Done? We have done that already. You were at this step. Then now x, y and z. So you will be reading it here. Z is equal to minus 1. Z is equal to minus 1. Next y plus 2z is equal to 0. Y plus 2z is equal to 0. Now you will be putting z over here and you will be getting the value of y. So y 2 into minus 1. So it gives you y is equal to 2. Now x plus 2y plus z is equal to 1. Now put z and y both in first equation. So you will be getting x. So x is equal to minus 2. Right? As rank of coefficient matrix is equal to rank of augmented matrix and that is equal to 3, which is equal to number of variables. Therefore, system has unique solution. And solution is what? X is equal to minus 2, y is equal to 2 and z is equal to minus 1. So this is your solution. Is it clear? Any doubt, beta?
Excuse me, ma'am.
Yes, beta.
Can we convert the coefficient matrix into a identity matrix and directly write the value of x, y, z from there?
Yeah, but you want to make this zero, as well as this zero.
Yeah, ma'am. Sometimes it's pretty normal then also.
You can do it, no issues, beta. We do that in the method, Gauss elimination method. Probably in that we do like that. But क्या होता है कि we can reduce number of row operations. Rather to simple calculation हो जाएंगे यहाँ से हमारे पास. Getting my
Okay,
point?
ma'am.
You need to make this zero as well as this zero with the help of this row operation, and then you'll be making this zero with the help of this R2. So you will be increasing your labor, your calculation. Right now, it would be very easy to put all these in this equation rather to apply 3 more row operations. Right?
Yes, ma'am.
Otherwise, no issue. You can put it this zero, this zero, this zero, and then you'll be checking rank, and then you can write x plus 0 time of y plus 0 z is equal to something. Calculation would increase.
Okay, ma'am. I
Okay?
will do it like this. Okay.
See, it is 3 cross 3 matrix, right? And if you will be having 4 cross 4, 5 cross 4, or 6 cross 6, so in that matrix, whatever operation you have applied to make this upper triangular na, same number of operation you need to make making these zeros, right? ना तो उसमें calculation increase हो जाएंगे आपकी.
Okay, ma'am.
ठीक है?
Thank you.
Okay, beta. So this is your solution. Right? Now this would be solution, and this solution would satisfy all these 3 equations simultaneously. So for checking your solution is right or wrong, you can put x is equal to -2, y is equal to 2, and z is equal to -1 in this set of equations. And you can check it, all are verified. Now what is the meaning of the solution? Metrically, there are 3 planes and they are intersecting at this unique point, right? System is having unique solution, so they are intersecting at this point where x is equal to -2, y is equal to 2, and z is equal to -1. Now, let us have another example. Solve 3x minus 2y plus 2z is equal to 6, 2x minus 3y plus 4z is equal to 0, 7x minus 3y plus 2z is equal to -1. Solve the system of linear equation. So first step is write augmented matrix. Everyone write in your notebooks. Write augmented matrix. 3 minus 2 plus 2 and 6. 2 minus 3, 4, 0. 7 minus 3, 2 and -1. So this is your augmented matrix. So what we can do to avoid the fraction, we can make this entry as 1. Right? So you can make it 1 here using the operation R1 implies R1 minus R2. Right? So you are just making for calculation without fraction. So you are making this 3 minus 2, 1, minus 2, plus 3, 1, 2 minus 4, minus 2, 6 minus 0 is 6. Right? After that, you need to make this entry 0 as well as this entry 0. So you are applying the operation R2 implies R2 minus 2 times of R1, and R3 implies R3 minus 7 times of R1. Hurry up, solve it.
May I?
Yes, Satvik?
Then the values will be 0, 5, 8, minus 12.
Just wait, beta. 1, 1 minus 2, 6. Then 0. Then 5,
Yes,
5. Next,
8,
8
minus 12.
minus 12. Okay. Have you done next row also? Okay, do it.
In the second row, the second element shouldn't be minus 5.
This one, beta? This?
Ma'am, yes, ma'am, minus 5 it should be.
Yes, it is. R2 is minus 3. And then
Yeah, ma'am.
minus twice of 1 is this. It would be minus 5. Yes. Satvik, beta, corrected, please.
Okay, ma'am.
Yes, what will be next row? This is to 0. Minus 3, minus 7, it would be minus 10. And then 2 minus minus plus, it is 16.
And minus 43.
Sorry, beta, minus of 43. Okay, so let us see what we are getting it. Yes, right? After this, minus 5, 8, minus 12, minus 10, 16, and minus 43, right? Now, next is we will multiply the second row with minus 1 by 5. So it would be 1 minus 8 by 5, 12 by 5. And then we need to make this entry as 0. So you will be applying R3 plus 10 times of R2. R3 implies R3 plus 10 times of R2. Do it, hurry up. Yes, done. So you are getting it 0, 0, 0, 0, 0 minus of 19. Is it right, Shubham?
Yes, ma'am. I'm
Okay.
getting this.
Now, yes, beta.
Nothing, ma'am.
Okay, beta. After that, this is your row echelon form. Now you need to find out rank of augmented matrix and rank of coefficient matrix. Right? So what is the rank of augmented matrix? You need to count number of non-zero rows. So this is 1, this is 2, and this is 3. So rank of augmented matrix is 3. Now, rank of coefficient matrix. Now you will forget this column and you will concentrate only these entries. This is your coefficient matrix. Now count the number of non-zero rows, 1 and 2. This is completely 0 row. For coefficient matrix, this is your coefficient matrix, so you need to concentrate only on this for finding rank of coefficient matrix. So rank of coefficient matrix is equal to what? That is equal to 2. Right? So now rank of augmented matrix is not equal to rank of coefficient matrix. So this means system has no solution, right? And if system has no solution, it means this system is what? Consistent or inconsistent?
Inconsistent.
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 Inconsistent. Inconsistent, right? So this means system has no solution. Is it clear? Inconsistent system with no solution. Any doubt? Okay. Now come to the next question. Solve system of linear equation 5x minus 6y plus z is equal to 4, 2x minus 3y plus z is equal to 1, 4x minus 3y minus z is equal to 5. Again, first step, write augmented matrix. Write it. 5 minus 6, 1, 4, 2 minus 3, 1, 1, then 4 minus 3 minus 1 and 5. Right? This is your augmented matrix. Again, to avoid the fraction, I'll try to make this entry as 1. So for making this one, I can do R1 implies R1 minus R3. R1 implies R1 minus R3. Calculate it and let me know.
It's 1 minus 3,
It's 1 minus 3,
2 and minus 1.
2 and minus 1. Good. So can we see in this next matrix? 1 minus 3, 2 minus 1, 2 minus 3, 1, 1, 4 minus 3 minus 1, 5. Good. Now, next, you need to make this 0 as well as this 0. So you will be applying the operation. R2 implies R2 minus 2 times of R1. R3 implies R3 minus 4 times of R1. Calculate it. Everyone, please calculate it.
गोल्डन एरो दिया था उमेश उससे जाके मैंने बात करना शुरू किया I saw you there and I'm like yeah Bhumika and then I heard your name I'm like bam she's here I actually knew but golden hearts wanna be mine
Harleen, kindly mute yourself.
I'm gonna take granted of that I'll never take that for Pakka
Harleen,
May I?
just wait, beta.
She's also a
Harleen,
good personality like I know you but she's from Jammu you know okay so I think I should go and talk
yes, beta. Who was telling me?
May I?
Yes, Satvik, beta.
The row 2 will be
Hmm.
0, 3, minus 3, 3.
0, 3, minus 3,
3.
3. Okay. And R3?
And ma'am, 0, 9,
0, 9,
minus 9, 9,
minus 9,
9.
9. Okay. So 1 minus 3, 2 minus 1. Right? So now let us see. Correct? 1 minus 3, 2 minus 1, 0, 3 minus 3 minus plus 3, 0, 9 minus 9 and 9. Now, you can multiply this R2 with 1 by 3 and you're making it 1 minus 1 and 1. Done. And after that, I need to make this entry 0. So you will be applying again R3 implies R3 minus 9 times of R2. R3 minus 9 times of R2. So it is same. It would be 0, 0 and 0. Whole row is, complete row is 0 now. Now after that, this. Tell me rank of augmented matrix and rank of coefficient matrix. Now I'll announce any name who will tell me rank of coefficient matrix and rank of augmented matrix. Niharika. Niharika. Okay, she's not responding. Prikshit. Prikshit. Not responding. Okay. Raghav. Ria. Ria. Uday. Uday. Yashika. Am I audible, beta? Okay. Yes. Yashika, tell me the rank of augmented matrix.
Ma'am, I haven't done this one.
Beta, I have done it for you, beta. You can see the screen.
It's 3.
Why it is 3, beta? Can you tell me how we find the rank of any matrix after converting it into echelon form?
No, ma'am, it's 2.
Yes.
Rank equals to number of non-zero rows.
Yes. So rank of augmented matrix would be
2.
2. Now tell me the rank of coefficient matrix. What is the coefficient matrix?
It's 3.
Why it's 3? Not acceptable, beta. Very wrong. So this is your coefficient matrix. For finding the rank of coefficient matrix, you will forget this column, right? And concentrate on this. And in this matrix, you can see again number of non-zero rows are 2, 1 and 2. So rank of coefficient matrix is equal to rank of augmented matrix, and that is equal to 2. That is less than number of variables. How many number of variables are there? 3. right? X, Y, and Z, three number of variable. So rank is less than number of variable, but both are same. It means system is consistent, but system has infinite many solution, right? System has infinite many solution. Now you have written here rank of coefficient matrix is equal to rank of augmented matrix, and that is equal to 2, which is less than 3 number of variable. So it means system has infinite many solution. So in that case, what you will do, we will suppose one variable. Let us suppose Z is equal to K, right? And then you will write it 0x plus y minus z is equal to 1 and put the value of z in this. So you will be getting y is equal to 1 plus k. And from first equation, x minus 3y plus 2z is equal to minus 1. So you will be putting here x minus 3 y plus 1 plus k minus 3k plus 2k is equal to minus 1, right? So it would be x is equal to, this is minus k, and it would become here k, and this come here, it would be k plus 2, right? So z is equal to k, y is equal to 1 plus k, and x is equal to k plus 2. Right? There is no need to do this. If you want to do, then you can do. Otherwise, from this, I'm supposing you, whenever you are having infinite many solution, so 3 number of variable minus rank, that is equal to 1. Here is one independent variable. So you have supposed that z as an independent variable and z can take any value. We are supposing z is equal to k and k can be any real value, right? And after supposing z is equal to k, you will represent other variables in terms of k. So your solution would be z is equal to k, y is equal to k plus 1 and x is equal to k plus 2. So solution is given by this, right? Is it clear? After finding the rank, rank is 2, which is less than number of variable. So number of variable minus of rank will give you independent solution, right? So here n minus r, n is what? Number of variable, r is rank. So number of variable minus rank is equal to 1. It means you can suppose one independent solution. So we have supposed z as a k and then x and y, you can write x and y in terms of k. Right? Now k can have any value. Now, for example, we are taking this z is equal to 1. It means you are taking k is equal to 1. If k is equal to 1, then y would be 2 and x is equal to 3. So similarly, you can give any value to this k. So this is how you will write your infinite many solution. So if you are supposing z is equal to 1, corresponding y is 2, x is equal to 3, you can check, you can put in your given equation and it will be satisfied. So it will work for all three equations. Similarly, you can try z is equal to 0, z is equal to 1, 2, 3, whatever. So solution would be written in this form, x, y, z. Is it clear, beta?
Yes, ma'am.
Yes, ma'am.
Okay, so noted down this question is your homework. Check for the consistency for the following system of equation. System of equation is given to you, right? And you need to check whether it is consistent or not. If it is consistent, then find its solution. If it is inconsistent, it means it has no solution. Let us have next question. Find the value of lambda and mu so that the system of equation 2x plus 3y plus 5z is equal to 9, 7x plus 3y minus 2z is equal to 8, 2x plus 3y plus lambda z is equal to mu. Have number 1, no solution. Number 2, unique solution. Number 3, infinite many solution. Find the value of lambda and mu so that this system has unique solution, no solution, and infinite many solution. Take 2 minutes and try to solve it. How can you proceed? You can reduce this given system of linear equation. Or first you'll write augmented matrix and then try to convert into echelon form and then puts condition on lambda and mu. Take 2-3 minutes, try it. Yes, beta, are you trying? Shubham, Satvik?
Yes, ma'am. Ma'am, will
Okay,
the
Yes,
do.
ma'am.
answer be in range form?
Sorry, beta.
Answer be in a form like it will be lie between this from this to this or
No, no,
something
no,
like
you
that.
will getting exact value, beta.
Okay.
You will be getting exact value.
Okay.
Okay, I'll help you. Let us start. Write given matrix, augmented matrix for given system of linear equation, right? So we have written this 2, 3, 5, 9, 7, 3 minus 2, 8, 2, 3 lambda and mu, right? Just to avoid fraction, we will try to make 1 at any place in this first row, second row, or third row. So what I'm trying here, R2 implies R2 minus 3 times of R1, right? So after doing this, you will be getting this 1 minus 6 minus 10 and minus 12, right? Just for sake of calculation. And then we will interchange this R1 and R2. Sorry, it is R2. Interchange R1 and R2 and you are at this step, right? Now you will tell me, we will be applying operation. R2 implies R2 minus 2 times of R1. Okay, for making this entry 0. And similarly for this 0, we will be applying operation. R3 implies R3 minus 2 times of R1. Calculate it, beta. And then let me know. Tushar 5049. Are you there, beta? Tushar Shekhar, are you there? Yes, Tushar. Calculate it and let me know what will be the entries. First row as it is, 1 minus 6 minus 12 and then minus 10. For this it would be 0. Now tell me next entries.
May I?
Wait, Satvik. Yes, Tushar. Are you doing? Yes, Satvik beta.
It will be 15, 29, 29.
15, 29, 29. And third row,
0, 15,
0, 15,
lambda plus 24,
lambda plus 24,
and nu plus
and
20.
mu plus
20.
20. Okay, let us check. Absolutely right. Now, next target is we need to make this entry 0. So we will be applying R3 implies R3 minus R2. So making this 0, we will take the help of R2. So R3 minus R2. Calculate it.
Ma'am, may I tell?
Yeah, sure. Shubham, please.
Ma'am, 0, 0, then lambda minus 5,
So I can change in this matrix, no? In this. Yes, beta. Tell me.
I'm 0, 0, lambda minus 5,
Lambda minus 5
and then
and
mu minus 9.
mu minus 9. Good. So let us check. Done? Right? Good. Now, after that, you need to find out the condition for no solution, right? And then for infinite many solution and for unique solution, right? So let us discuss first no solution. For no solution, condition is what? Rank of coefficient matrix should not equal to rank of augmented matrix, right? I need this for existence of this no solution. So now you tell me what condition we can put here.
Ma'am, first of all, lambda minus 5 will be equal to 0.
Yes, so it means lambda is equal to 5, right?
Ma'am, yes, ma'am. And mu minus 9 should be greater than 0 uh, for it to be true.
For what, beta?
I'm like lambda minus 9 can't be equal to 0. Otherwise,
So I
it will
can
be.
say that mu minus 9 cannot equal to 0, right? So in mean you can say that mu cannot equal to 9, right?
Yes, ma'am.
Right now. So when you are making lambda is equal to 5, so it would become 0. And if it becomes 0, then rank of coefficient matrix would be 2. Right? If this entry is 0 and this entry would be 0 when lambda is equal to 5. So we are putting lambda is equal to 5. So it becomes 0. So rank of this coefficient matrix would become 2. And mu should not equal to 9, because if mu is 9, then it would become 0. And if it would become 0, then rank of augmented matrix would be 2. And that would be the same as coefficient matrix, which we don't need for no solution. Condition for no solution means rank of coefficient matrix should not equal to rank of augmented matrix. So if I'm taking lambda is equal to 5, then rank of coefficient matrix would become 2. And if mu is not equal to 9, then rank of augmented matrix would be 3. And both are unequal, both are not same. So it means system has no solution. So for no solution, lambda should be equal to 5 and mu should not equal to 9. Right? So for no solution, lambda is equal to 5 and mu should not equal to 9. Now, next is for unique solution. For unique solution, we do have the condition rank of coefficient matrix is equal to rank of augmented matrix, and that should be equal to number of variables. So here number of variables are 3. So now tell me what condition should be there for unique solution.
Ma'am, lambda should not be equal to 5 and mu shouldn't be equal to 9.
Right? If lambda is not equal to 5, it means this entry would not be 0. And if it would not be 0, then rank of coefficient matrix would be 3. Right? Now next is beta mu. Yes, Shubham, what you have told beta?
Be equal to 9.
Mu is equal to 9. Why?
It should not be equal to 9.
Okay, should not equal to 9. But if let us suppose mu is equal to 9, let us suppose it would is equal to 9, then this entry would become 0. Right?
Yeah, ma'am. Then it will be the first condition. No?
First condition means beta, again rank of coefficient matrix, still it is rank of coefficient matrix is equal to 3. Because this is non-zero, na? So this become non-zero row.
Yeah, ma'am. Yeah.
So it means what?
Ma'am, it can be equal to 9.
It can be equal to 9. It cannot be equal to 9. So in other words, I can say that mu can have any value.
Hello, ma'am. Hello.
Right?
Yes, ma'am.
Na? Mu can have any value. Again, I'm repeating this.
We can say vice versa also, na?
No, beta. Vice versa also in terms of what? You can say, you want to say
not
that?
Be equal to 9. Okay, ma'am, I understand.
Because of coefficient matrix,
Yes,
this
ma'am.
element matters, beta.
Yes, ma'am, yes.
है ना? तो condition depending upon this.
Okay, ma'am.
If it is non-zero ना, तो चाहे ये भी zero हो जाए, it's hardly matter because this entry making this non-zero row. Am I clear?
Yes, ma'am.
Yes, ma'am.
So I'm repeating it again. We need for unique solution rank of coefficient matrix and rank of augmented matrix both should be same, and that is equal to number of variable. So in this question number of variables are 3. So rank of coefficient matrix and rank of augmented matrix both must be is equal to 3. Right? So now we are putting the condition this should not be equal to 0 for rank of coefficient matrix to be 3. Right? So we impose this ki lambda minus 5 should not equal to 0. It means lambda should not equal to 5. Done ho gaya? Now, using this value, rank of coefficient matrix would be 3. Now, come to the rank of augmented matrix. There should not be any condition for this entry. Why? Because of this entry, if it would become 9, अगर मैंने mu को 9 डाल भी दिया, तो it would become 0. And if it is 0, even though this row is a non-zero row, and rank of augmented matrix would be 3. And if it is not equal to 9, means it may be 8, 7, whatever value, so you will be having here non-zero value. Again, rank of augmented matrix would be 3. So in any case, mu can have any value and lambda should not equal to 5 for unique solution. Right? Now come to the third, infinite many solution. What condition can be there for infinite many solution? In
Lambda
infinite
is
many
equal to
solution,
5 and mu is equal to 9.
lambda is equal to,
5 and mu is equal to 9.
and who is telling me this?
Ma'am Niharika.
Niharika. Okay, beta. Lambda is equal to 5 and mu is equal to 9. Why, Niharika? If I'm taking lambda is equal to 5, then what will happen?
Ma'am, then that term will be 0 and then rank of augmented matrix and rank of
No. Just
quotient.
concentrate. If you are putting the condition on lambda, I'm asking about lambda only. If you are putting lambda is equal to 5, then you are absolutely right. It would become 0. And if
0.
it would become 0, then rank of coefficient matrix would become 2.
2. Yes,
Right?
ma'am.
And if you're putting this condition, mu is equal to 9, it means this entry would be 0. And in that case, rank of augmented matrix would
Be
be
2.
2. Right? And this is the condition for existence of infinite many solution. Rank of coefficient matrix should be equal to rank of augmented matrix, and that should be less than number of variables.
Variables.
Right, absolutely right. Thank you, Niharika. I'm happy. Except Satvik and Shubham, someone is responding. I hope it is clear, everyone.
Yes, ma'am.
Yes, ma'am.
Okay, beta, thank you. Now, this is your homework. Note it down. You need to solve the system of this equation, and in this you need to find out value of k, so that system has infinite many solution. And let us say if you are having two values of k, then you need to solve for any value of k. Now come to next, solution of homogeneous system of linear equation. Ax is equal to 0, null matrix. If right hand side of all equation is 0, then the system is known as homogeneous system of linear equation. If rank of coefficient matrix is equal to n, and that is number of variable, there is no role of augmented matrix. Why? Because right hand side of all equation is 0. So there is no role of augmented matrix. We will concentrate only on coefficient matrix. The rank of coefficient matrix is equal to n, that is number of variable. Then system is consistent and system has trivial solution. Trivial solution means everything is 0. X is equal to 0, y is equal to 0, z is equal to 0, and so on. If rank of coefficient matrix less than n, number of variable, then system has infinite many solution. And in both the cases system is consistent. Right? System is consistent and has infinite many solution. When you are having a solution other than 0, 0, that solution is known as non-trivial solution. And if you are having complete solution as 0, then it is trivial solution. Right? So in any case, homogeneous system is always consistent. Right? Because in non-homogeneous system, we put the condition for inconsistency when rank of augmented matrix and rank of coefficient matrix both are not same. Then we say that system is inconsistent. But here, right hand side is completely 0, so there is no role of augmented matrix. Right? In any case, rank of both matrices would be same. So homogeneous system is always consistent. Keep in mind, and it is consistent, so you can have either trivial solution or non-trivial solution. If rank of coefficient matrix is equal to number of variable, then system has trivial solution. And if rank of a coefficient matrix is less than number of variable, then system has infinite many solution. Now, if number of equations is equal to number of variable, right? If number of equation is equal to number of variable, to have a non-trivial solution, determinant of matrix should be equal to 0. Let us have x plus y plus z is equal to 0. 2x plus 3y plus 2z is equal to 0. Or x plus 2y plus z is equal to 0. Number of equation 3. Number of variable 3. To have non-trivial solution. Non-trivial solution means rank of this coefficient matrix must be less than n. Right now, for non-trivial solution, rank of coefficient matrix must be less than n. And when it is possible? Only when determinant of A is equal to 0. For non-trivial solution, for this example, for non-trivial solution, rank of coefficient matrix must be less than 3. Right? If it is equal to 3, then it would have trivial solution. So for having non-trivial solution, rank of coefficient matrix must be less than 3. Right? And iska rank 3 se less kab hoga? When determinant of this would be 0. Right? This coefficient matrix would become singular. Is it clear? Yes or no?
Yes, ma'am.
Yes, ma'am.
Got it now? We do have this property. If determinant of matrix is equal to 0, it means rank of matrix cannot equal to 3 because this is 3 cross 3 matrix. And if determinant is equal to 0, so rank of this matrix cannot equal to 3. It must be less than 3. It may be 1, it may be 2. Right? So if number of equation is equal to number of variable, to have non-trivial solution, determinant of that matrix must be 0. If number of equations is less than number of variable, then system has always a solution other than trivial solution. Obviously, if I am putting one variable over here, right? 4 variables and 3 equations. So number of equations are less than number of variable. So when you are finding the rank of coefficient matrix, so maximum it would be 3, and which is less than number of variable. So if rank of coefficient matrix is less than number of variable, then system has infinite many solution. And if it is infinite many solution, it means it is non-trivial solution. Let us have an example. Check the consistency for the following system of equation. Let us check it. So first we will write coefficient matrix. So what is the coefficient matrix? 1, 1, x, y, z, minus 1, w, 1. Right? And then next row is 1, minus 1. It is 2 and minus 1. Last row is 3, 1, z is 0 and w is 1. Right? Okay, write these coefficient carefully. X coefficient 3, y coefficient 1, z coefficient 0 and w coefficient 1. Now, you need to convert it into echelon form. You need to find out rank. So let us apply this operation. R2 implies R2 minus R1. Right? R2 minus R1, and then R3 implies R3 minus 3 times of R1. Now calculate it, hurry up and let me know what will be the entries. 1, 1, minus 1, 1. This is 0 and this is 0. Tell me the entries of second row.
Minus 2, 3 and minus 2.
minus 2,
3 and minus 2.
and 3 and minus 2. Yes. Third row,
Ma'am, the same.
exactly same. 1 minus
Yes.
3
Yes, ma'am.
is 2, 0, it is 3, yes, and 1 minus 3 minus 2. It is same, right? Now, next operation would be, we need to make this 0, so we will applying R3 implies R3 minus R2. So it is exactly same, this row would become 0. So I'm writing it here. This is 1, 1, minus 1, 1. 0, minus 2, 3, and minus 2. And 0, 0, 0, and 0. Right? Now, rank of coefficient matrix is equal to what? Yes? Tell me, beta. Rank
Ma'am,
of,
2.
it is 2. Number of non-zero rows are 2. And that is less than number of variable. Number of variables are 4. So it means system has infinite many solution. Now, how you will write? System has infinite many solution. So in that, number of variable minus rank of given matrix. So number of variables are here 4 and rank is what? 2. So 4 minus 2 is 2. There would be 2 independent solution. So you can suppose let W is equal to K1 and Z is equal to K2. Right? W is equal to K1 and Z is equal to K2. Now rewrite this equation. Minus of 2y plus 3z minus 2w is equal to 0. Right? So you will write y in terms of K1 and K2. So y is equal to 2w, this side you take it this side, 2k1 minus 3k2 and divided by minus 2. Right? This is your y. And similarly, from first equation, we will be writing x plus y minus z plus w is equal to 0. So x can be written as, it is z plus, so I'm writing k2, w minus, the minus k1 and minus y. So minus minus plus, you can write here 2k1 minus 3k2 divided by 2. And then you can simplify it. And k1, k2 can have any value. K1 and K2 can have any value. Right? Is it clear?
Yes, ma'am.
Okay. So that's all for today. This is your homework. I'll share this PPT with you all. Then you need to solve all homework.